Hello children, welcome to Zero Panic Maths. In today's session, let us continue our discussion on the end of chapter exercises. But before that, in the previous session, just after completing the exercise set 4.5, we are left with two worked examples. Okay, example 17 and example 18. Okay, if you remember, let us first resolve these two examples and then we will continue our discussion on the end of chapter exercises. Okay, now there is an example 17. It says Saira has arranged a square of side x units. Okay, you can observe these informations given, but before we start discussing this, let me know you that you have to go through all the sessions that are covered in chapter 4. Go to the playlist and play all the videos and watch all the videos related to the chapter 4, because this is end of chapter exercises. And always, as I already told you, that end of chapter exercises usually covers all the concepts related to the chapter from the beginning. Okay, so I recommend you to watch all the videos based on chapter 4. Okay. Okay, now let us continue our discussion. This example also you will observe that. Okay, Saira has arranged a square of x units. There is a square of x units. Okay, one information. Second, 8 rectangular strips of side x units and width 1 unit. Okay, so there are 8 rectangles of x unit one side and another side is 1 unit only. Okay, here it is x unit as one side, that is the square, one square of x units, 8 rectangles of x and 1 as length and width. Okay, now and finally 15 squares of side 1 unit. Okay, finally 15 squares of 1 unit each are there to form a bigger rectangle. And combining all these squares, rectangles, she has formed a bigger rectangle. Okay, now what is the problem? Find the length and breadth of the rectangle in terms of x. Now area covered by a square of side x units. So if there is a square of x units at side, what is the area? It is x into x. So first thing is x square units. And how many such squares are there? There is only one. Now next, area covered by a rectangle. Rectangle will have one side and the other side of different lengths. Okay, so sides x units and 1 unit, so it will be x into 1, right? So it will be x into 1 x square units. But the thing is, there are 8 such rectangles, so we should be multiplying 8 to x. So total area covered by 8 such rectangles is 8x square units. Okay, so don't confuse here, this is x actually. Okay, this is not multiple symbol, this is x. Okay, so 8x square units is the area covered by 8 rectangles. Okay, and x square is the area covered by 1 square. Okay, now coming to the last part, there are 15 squares of side 1 unit. There are 15 squares. Square is again 1 into 1. Okay, so area covered by a square of side 1 unit is 1 square unit only, but there are 15 such squares are there. So total area covered by 15 such squares is 15 square units. Okay, now we have to combine all these, because they told that combining all, there is she formed a bigger rectangle. So we have to combine a square of x square units, x square units, 8 rectangles, sorry, 8x square units, 8 rectangles, and 15 square units squares, 15 squares. So combining all that, you see that total area covered by all the squares and rectangles is equal to x square 1 square, 8x rectangles, 8 rectangles, and 15 square units. So it is x square plus 8x plus 15. It is an algebraic equation. So finally what we want is solving that algebraic equation. We will find the length and breadth of the rectangle in terms of x. So let us resolve the algebraic expression, x square plus 8x plus 15. Okay, now as you know the rule of splitting the middle term, the factorization method. Okay, splitting the middle term so that the product will be 15 and the sum of those factors will be 8, and those factors will be 3 into 5. 3 5 is 15, 3 plus 5 is 8. So let me write this as x square plus 3x plus 5x plus 15. And you know that we will take some common thing from the first two terms, and that is x, and what remains inside is x plus 3. It is x here and 3 here. Again, from these two terms 5 I will take it as common, and what remains is x, and 5 3s are 15. It is x plus 3. Again, there are x plus 3 common, so what I will take is x plus 3 common, and what remains is x plus 5. Okay, so now this is what, now if you consider this as length, okay, and this as breadth, okay, so it is actually length into breadth. This is the area covered. So what do you mean by that? If this is the length and this is the breadth, then multiplying these two you will get this, and this is the whole area covered by all these geometrical shapes, that what they are explaining in the example. You understood this point? So since we got these as factors, we can consider in terms of x plus 3 as length and x plus 5 as breadth. So therefore the length of the rectangle, you can write that length, or you can directly say length is equal to x plus 3 units. In terms of x they are asking, right? So we are writing the same thing. Length is x plus 3 units and breadth is x plus 5 units. Multiplying x plus 3 and x plus 5, you will get this expression, and which represents the total area covered by all the squares and rectangles. So this is what the example says. You understood this? Okay. Now let us quickly move to the next problem. Problem number example 18. Okay. A rectangular pool is such that its breadth is 4 meters less than its length. Okay, and its area is given here. Area is 96 square meters, and that area, you know that you will get it by multiplying length and breadth. Okay, so let us represent the length in terms of x and breadth x minus 4 minutes, because it says breadth is 4 meters less than its length. So we have to finally find length and breadth of the pool. So there is a pool. Okay, let us represent, let length of the pool, length of the pool is equal to x meters. Okay, is equal to x meters. You can write meters only. Now since it is given that breadth is equal to, breadth is 4 less than the length, right? 4 meters less than that. So from length we have to subtract 4, and that is x minus 4 meters. Okay, now multiplying length and breadth, we will get the area. So therefore area of the pool, okay, area of the pool is equal to, we know that length into breadth. Okay, so you can write it fully, length and breadth. So area of the pool, they have already given it as 96 square meters. So I can write this as 96 square meters. And what is length? Length is x, and what is breadth? Breadth is x minus 4. So let us multiply this, and it will get you a algebraic expression, solving which we will get the value of x. Okay, by that way we will get the length and we can get the breadth also. We multiply that, x square minus x into 4, that is minus 4x, and then taking 96 to that side. And finally you can take 96 also to this side. This will be x square minus 4x minus 96 is equal to 0. Now we have to resolve this expression so that we will get some value of x. Okay, let us resolve that again by using the factorization method. So the product here is minus 96, and what I want is I have to get two such factors whose sum is minus 4 and product is minus 96 obviously, and that is 8 into you can say 12 and minus 12. Okay, so 8 minus 12 is minus 4, and 12 8 it is 96 with the minus symbol. Okay, I think you got it. Okay, now let me write this as x square plus 8x, okay, and minus 12x minus 96 is equal to 0. I just split the middle term into this format. Okay, let me take x as common, so it will be x plus 8 from the first two terms. Okay, you're getting this right? Okay, again I have to take minus 12 as common here, so what remains here is x in this term, and in this term 12 8 it is, so it will be plus 8 and it is equal to 0. Again x plus 8, x plus 8, that is the common thing, that x plus 8 I'll take it as common. What remains inside is x minus 12 is equal to 0. Now, this equation says that x plus 8 multiplied by x minus 12 is equal to 0. It means that either this factor, the whole thing x plus 8 should be 0, or x minus 12 should be 0 to make this whole expression equal to 0. So let us consider that x plus 8 equal to 0, or x minus 12 is equal to 0 will get me the whole expression 0. We are actually equating both the factors to 0 to get a proper value. Okay, so therefore either x is equal to, take the plus 8 to that side, it will become x minus 8. Okay, and x minus 12, if I take it to the right side, it will get me x is equal to 12. Now, what should be, there are two values of x we got, but what should be the actual value of x? X should be 12. Why? Because another value of x is negative, and what our initial assumption is, length of the pool, we are considering it as x. So length never be a negative number. Okay, so if we are representing length as x and that is a length of the pool, you cannot have minus 8 as that value. So ignoring negative numbers, we can consider x is equal to 12 meters as the length of the pool. That is what the conclusion is. So whenever you get some negative numbers and you have assumed initially that it is a length or breadth, then you have to ignore negative numbers. That is what the conclusion is. Okay, so you can write here that since x is length, x is length, you can ignore the negative number. So since x is length, ignoring the negative numbers, you can say ignoring the negative factor or value, you can say negative factor, x is equal to 12 is the length, is the length you can consider. Or finally you can write x is equal to 12 is the length of the pool, length of the pool. So that is one thing. So finally you can write length is equal to x is equal to 12 meters, and based on the length itself we have breadth also, because breadth is given as 4 meters less than the length. So therefore breadth also, they want that length and breadth as the final answers. That finally breadth is equal to x minus 4, and that is 12 minus 4, which is equal to, sorry, 12 minus 4, and that is equal to 8 meters. So this is the answer to the question that they wanted a length and breadth. If you multiply 12 to 8, 12 8s are 96, and that is the area of the pool that they have already given. This is how you actually verified the answer also. Okay, so hope you got this. Let us quickly move to the end of chapter exercises now. Okay, now to start with end of chapter exercises, because it covers all the kind of identities that what we have studied in our chapter, you have to go through all the identities once again and then start with the end of chapter exercises. Okay, now they are saying that use suitable identities to find the following products. Okay, now you can see it here, it is minus 3x plus 4. Either you can write it as 4 minus 3x and apply a minus b whole square formula, or consider minus 3 as a and apply a plus b formula. Both will get you the same answer. Okay, whatever method you want to follow, you can follow that. So let me write this as 4 minus 3x for me. Okay, writing minus 3 as b, minus 3x writing to the right side will make 3x as b. Okay, sorry, it is 3x as b. So it is now a minus b, where a is 4 and b is 3x. And what is the formula for a minus b whole square? It is a square minus 2ab, where a is 4 now here, 2a, and b is 3x, right? Plus b square, that is 3x whole square. Okay, a square minus 2ab plus b square. A square is 16 minus 2 4s are 8, 8 3s are 24, right? 24x plus 3 square, that is 9, and x square. So let us write, you can keep this also as the identity, sorry, the expanded version of this or the product of this. But you can write the x square terms beginning in the beginning, that 9x square, and keep the middle term as 24 only. Okay, so 24x, and then finally write 16. So this can also be the expanded version of this. Now let us quickly move to the second problem, because we have done so many problems of the similar kind already in the previous exercises also. We can go faster. Okay, now look at this expression here. There are two factors, 2s plus 7 and 2s minus 7. What do you think of it? It is a plus b and a minus b. A is 2s, b is 7. Okay, so you can write it as a plus b. Okay, let me write that a plus b, a minus b, and what is the value of this? Is a square minus b square. This is the given identity. So it is already given as a, as here a is equal to 2s and b is equal to 7, so that it is a square, that is 2s whole square, minus b square, that is 7 square. A square is 4s square minus 49. Okay, nothing else. Okay, it is, if you multiply also, you're going to get this only, and we have proved this by using this identity. Okay, there are so many such similar problems only are given in the next coming problems also. Okay, now let us quickly go to the third problem. Again, this is also a plus b, a minus b, but the difference here is a itself is p square here and b is 1 by 2. Okay, so here a is equal to p square, okay, and b is equal to 1 by 2. Okay, now writing a plus b, a minus b as a square. Okay, so a square is p square, p square is a, so the square of that, a square minus b square, b square is 1 by 2 whole square. Okay, so as I already told, the rule of exponentiation, a to the power of m to the power of n will make it as a to the power of m into n, that is 2 2s are 4, and p to the power of 4 minus 1 square in the numerator and 2 square in the denominator, that is 1 by 4. So this is what the value of this. Okay, so there's no difference at all. So here also it is 2n plus 7, 2n minus 7. I think it is exactly similar to the previous problem. You see that instead of yes, they have given it as n. Okay, there is no difference at all. Okay, I don't know why they have given a similar, exactly similar problem. It is 2n plus 7 and 2n minus 7. If you see that, it is the fourth problem. Instead of yes, they have given it as n. So we can directly write the similar answer here. Okay, it is 4n square minus 49. You can write that yourself. Okay, I will not spend time on that. Okay, let us quickly go to the fifth problem now. Okay, now there is a different problem here. You see here, it is s minus 2t s square plus 2st plus 4t square. In the previous session itself, we have studied one identity, or we have derived an identity by using the two factors. Okay, if you remember, I will write that. Okay, we know that this factor is x minus 1. It is looking like x minus y, x square plus 2xy x square plus xy plus y square. Let me write that first. It is x minus y, okay, and x square plus xy plus y square, and it was equal to x cube minus y cube. You remember this? Okay, there was an identity like this, so it is matching this identity. Okay, so that is the reason I told you that you have to remember all the identities. That will make your job easy. Okay, now here what is x? What is x? X is yes, and what is y? Y is 2t. So considering x as s and y is equal to 2t, we can expand this because this is in the expanded version only, and we can write that directly that as x cube minus y cube. Let me first write this. Okay, s minus 2t, that is x minus y, and then let me write this as s square plus xy format. It is xy, right? So let me write x is yes. Okay, x is yes here into 2t. You see that now? Now it is looking like 2st. I have written it as s into 2t as x and y. Okay, plus 2t is y, right? So let me write that as 2t whole square. Now it is looking like a b square for you now, or sorry, y square. It is x square plus xy plus y square. Now it is exactly looking like this. Okay, you can compare that. So let me just write that as x cube minus y cube. And what is x cube? What is x cube? That is s cube. S cube minus y cube. Y cube is 2t cube. 2t cube. And finally, you have to expand this also, right? So it is s cube minus 2 cube is 8 and cube. It is s cube minus 8t cube is the factor of this. Let us quickly go to the sixth problem. A minus b whole square. It is looking like a minus b whole square, where a is 1 by 2r. So you can write this as here a is equal to, you can consider that as 1 by 2r. Okay, and b is equal to 4r. A minus b whole square, that is a square. So therefore it is a square 1 by 2r whole square minus 2ab. Okay, 2ab, a is 1 by 2r. Let me write that as 1 by 2r. And b, what is b? B is 4r plus b square, that is 4r whole square. Okay, now this 2 and this 2 got cancelled, and this r and r also got cancelled. Okay, you just concentrate here and write it properly. R and r also are getting cancelled here. So what remained in the middle term is only 4 into 1, that is 4. Okay, and this is equal to 1 square in the numerator remains as 1, 2 square, and that is 4r square. Okay, minus 4. Okay, plus 4 square, that is 16r square. You can write this like this only, or else 16r square you can write it in the beginning and keep minus 4 in the middle and 1 by r square at the end, or else this is only the expanded version of this. Okay, that's all. Okay, if there are any small mistakes in the squares and sums, you can just re-verify and adjust those. Okay, now let us go to the next problem and see. It is a plus b plus c whole square. Whenever there are three terms and there is a square, it is a plus b plus c whole square only. Okay, and what is a plus b plus c whole square? Okay, you have to remember that. Okay, it is a square plus b square plus c square. First of all, the sum of the three square terms, and then 2ab plus 2bc, sorry, all these are plus only, 2bc and 2ac. Okay, okay, if you remember, then it will be good, or else you have to write it and remember it. Okay, now where you can say here, okay, whatever may be the signs, just consider the values with the signs. A is equal to minus 3m, a is equal to minus 3m, and b is equal to 4k, and c is equal to minus l. minus L. So this is L, okay? This is not N. Sorry, it is not 1, it is L. Okay, now let me write this expanded version by using these A, B, C values. Expanded version, A square, that is 3 minus 3m whole square, plus B square is 4k whole square, plus C square is minus L whole square, plus 2ab. A is minus 3m, okay? So minus 3m and B is 4k. B is 4k plus 2ab it is now, plus 2bc. 2b, what is b? B is 4k, C is minus L, okay? And then finally plus 2ac. A is minus 3m, okay? And C is minus L. So we are done with the expansion. Let us calculate the final values. So since it is minus 3 square, it will give me plus 9 only. We know that already. Plus 9m square. Okay. It is 4 square, that is 16k square. Okay. Again minus L into minus L, that is plus L square. Okay, now coming to this plus with this minus will make this whole term as minus. This whole term will become minus. Now first multiply the constant terms. 2 3s are 6, 6 4s are 24. Okay, and the variables mk. First of all, the sign, then constants, then variables. That's what simply we have to do. Again, same thing here also. It is plus and there is one minus with L, that makes the whole term as minus. 2 4s are 8. Okay. 2 4s are 8. K and L. It is 8 KL. And finally there is a plus here, but there is one minus, another minus. Minus into minus, that keeps this the whole term as plus only. Okay, let me write that. Plus 2 3s are 6. Okay, and then m and L, 6 ml, that is with plus. It is 9m square 16k square plus L square. Okay, now there is a small mistake. It is mk. Okay, so there is, it is 24 minus 24 mk. I missed that k here. Okay, so again this is minus symbol. Okay, make that correction. Okay, now this is what the final version of this. Let us quickly go to the next problem number 8, that is x minus 1 by 3 y. 1 by 3, 3 in the denominator and y is multiplied to this term, so I can consider y in the numerator itself. Okay, so it is looking like a minus b whole cube. You have to remember that formula also. Okay, a minus b whole cube is equal to a cube. You remember this? A cube minus 3a square b, okay, plus 3ab square and minus b cube. This is what the formula what we are going to use here. And here a we are considering it as x. A is equal to x and b is equal to y by 3. We can say b is equal to y by 3 or 1 by 3 into y, both are same only. Okay, so let us write x in place of a, that is x cube. Okay, minus 3a square is x square only. Okay, and b, what is b? B is y by 3. B is y by 3. Okay, that is with minus sign. Plus 3a, a is x, you know that. Okay, and b square, b square is y by 3 whole square. Okay, minus y by 3 whole cube. This is what the expansion. Now what we can do is this 3 and this 3 we can cancel. Again here also it will be 9 and 3 ones are 3 threes are will get cancelled, but we have to do it in the next step. Okay, so it is x cube minus x square y. Okay, what remains here is x square y plus 3x, okay, and multiplied by y square divided by 9 it is. Now I can cancel it. Okay, no problem. And it is y cube divided by 3 cube it is, so which is 27. Okay, So 3 threes are, sorry, 3 ones are and 3 threes are will get cancelled. Okay. Now what remains finally is x cube minus x square y plus x y square divided by 3. Okay. There is a 3 here. Shouldn't forget it. Okay. And finally minus y cube divided by 27. So this is the final step of that expansion. Let us quickly move to the next problem now. Okay. So it is the ninth problem, 7 by 2k. Again, it is a minus b whole cube only. Let me write that formula once again, but you have to remember it. A minus b whole cube is equal to a cube minus 3a square b plus 3a b square minus b cube. Okay. Here a is equal to, you have to substitute the values carefully. Okay. While doing the cube and squares, it's very important that you substitute the values carefully. Okay. It is 7 by 2k, or you can say 7k divided by 2 only. Okay. Because this k will be multiplied to the numerator only, and it is 2m by 3. I will write this, b is equal to 2m by 3. Okay. Now let us substitute and do the expansion. A cube is 7k divided by 2 whole cube. Okay. So it is 7k divided by 2 whole cube. It is a cube minus 3 a square. A square is 7k, 7k divided by 2 square. Okay. And b, what is b? B is 2m divided by 3. Okay. It is 3a square b plus 3ab square, and again a is 7k divided by 2. Okay. A, b square is 2m by 3 whole square. Okay. Do it carefully. 2m by 3 whole square, and then finally minus b cube, that is 2m by 3 whole cube. Okay. Now let us see in the next step what all things will get cancelled. Okay. 7 sevens are 49, 49 threes are, you can do that. It will be, I think, 343. If there is any mistake, you can do that. Okay. 343. K cube divided by 2 cube is 8. So this is the first term. Next term is, see, it is 2 cube 8, and there is a 3 here. I can just cancel this 3 and this 3, because this the whole term is with multiplication. Remember that. Okay. So now there is 7 square. Let me write that remaining thing. 7 square 49 k square divided by 4. First expand that, and then if there are anything that get cancels, you can do that later. Okay. We will do the cancellation in the next step. Okay. Plus again here also the 3 square will get cancelled with this, but we cannot do that until we expand this. 3 7k divided by 2 multiplied by 2 square is 4, and m square divided by 3 square, which is 9. Okay. Again minus, it is 8, because it is 2 cube 8 m cube and 3 cube, which is 27. Okay. 3 threes are 9, threes are 27. Okay. Now let us cancel the things. 1 2 ones are 2 twos are 49 divided by 2, it remains with, and 3 ones are and 3 threes are. Okay. There's anything that cancels? Okay. Yes, there is a 2 here, 2 twos are, you can do that. Okay. Anything else? Okay. Nothing. Okay. Let us write that now. Let us write this, the final step, as 343 k cube divided by 8. Okay. Minus, what remains here is 49 k square m. Okay. 49, do it carefully, because we have cancelled so many things. What are the remaining things? K square m and divided by 2 here. Okay. And then finally this term, so many things got cancelled here. 7 twos is remaining here. 7 twos 14k m square divided by 3. Okay. There is a 3 here, there is a 2 here. 7 twos that is 14k. That's why I'm telling you, do it carefully. 7 twos 14k m square in the numerator. K m square in the numerator. Denominator, it is only 3 that is remaining. So it is 14. Okay. So don't get confused. It is 14. And finally, there's no change in this. 8m cube divided by 27. Okay. So this is what the expansion of this by using this identity a minus b whole cube. Okay. It is b cube, right? Let us quickly move to the next set of problems. Okay, so it is the second set of problems. Find the values using the suitable identities. Here there are some products given. We have to convert those product values into the format where we can apply some identities. Okay, we have done such problems also previously. You will come to know when I write this. Okay, so it is 17 multiplied by 21. Okay, so if you write 17 multiplied by 21 in the form of an identity, you see 19 minus 2 and 19 plus 2 you can write this as. Okay, so there are two identities that I'm going to use it here. That 17 I'm writing it as 19 minus 2 so that it is a minus b, and 19 plus 2, you see that it is a minus b, and b value is 2 here, so a plus b. So it is looking like a minus b, a plus b, and we can directly write it as 19 square, that is a square minus b square. Sorry, b square is 2 square. You can directly calculate the value of 19 square, and that is also okay. 19 square subtraction 4 square also you can do, but 19 square itself, if you are feeling that it will be difficult to find, you can still one more step, you can extend this. Okay, so here you can write the value of this directly. That is one answer, but I'm giving you an extended version of this. 19, to make it little bit easier, I can write it as 20 minus 1 and whole square minus 2 square is 4. I can still extend this because it will be easy for me to calculate square of 20 rather than the square of 19. Okay, I can do that. A square, it is a minus b whole square now. So it is a square minus 2ab, that is 20 into 1, plus b square, that is 1 square, and minus 4. Okay, so now it is 2 to the 4 and 2 zeros. 400 is the square of 20, and minus 2 to the 4, that is 40, plus 1 minus 40, sorry, minus 4. So 400 minus 40, it is 360. Again a minus 4, 356, plus 1, it is 357. So this is the answer to 17 into 21. So as I already told, you can directly write 357 here also. Okay, that will be the answer in the two step only. But if you want to extend 19 also like this, you will finally get 357 very easily. Okay, you have to spend a little more time to it. Okay, now again this is also the same thing here. It is 100 plus 4. Okay, let me write. We have done so many such problems. Okay, it will be looking like a repetition for you. Okay, I'm writing 96 as 100 minus 4 and 104 as 100 plus 4. It is a plus b, a minus b, where a is 100 and b is 4. Okay, so I can write this as 100 square minus 4 square. It is a square minus b square. 100 square is 1 followed by 4 zeros, that is 10,000 minus 16. So it is directly 10,000 minus 16, it is 9,984. Okay, that's a simple answer to that product. Again the same product here also, I think you will calculate it very easily. 24, let us do it. 24 I can write it as 20 plus 4, and 16 I can write it as 20 minus 4. A plus b, a minus b, that is a square, that is 20 square, minus b square, that is 4 square. Okay, it is 4 followed by 2 zeros, 16, and it is 384. Let us quickly do this for 147. 147, you can write it as 150 minus 3, 150 minus 3 whole cube. it is now looking like a minus b whole cube. 150, since it looks like a nearby multiple of 10, I have written it as 150. It is a minus b whole cube. And you know the formula for a minus b whole cube. It is a cube. Let me write that as a cube minus 3a square b, a square, a is 150 here, okay, 150 square, okay, and b is 3, plus 3ab square, a 3, a is 150 and b is 3, okay, through 3ab square minus b cube, that is 3 cube. Okay, so there are some bigger numbers that you are going to get here. Okay, I think you can do that from now onwards. It is all number magic only. 150 cube, it will be a very big number. 150 square multiplied by 3 multiplied by 3 and all this. Okay, I think you can calculate some number, because this is what the expansion of this. Okay, I don't spend time on that. You can do that. Okay, I'll just give you the hint. Okay, here also the same thing happens. Okay, it is cube, and I can write this as 200 minus 1 whole cube. Okay, let me give that again as 200 cube, that is a cube, minus 3a square, that is 200 square, and b is 1. Okay, plus 3a square, ab square, a is 200 and b is 1, minus 1 cube, that is b cube. Okay, so 200 cube, okay, 200 cube is 8 followed by maybe 6 zeros. Okay, 8 followed by 6 zeros, 4 5 6. Okay, minus 3 multiplied by, it is 4 followed by 4 zeros. You see that it is 200 square, okay, plus 600, okay, minus 1 cube is 1. So do this also. Quickly moving to the sixth problem again. It is 127 cube. 127 cube also you will write it as 130 minus 3 whole cube. Okay, I don't spend time on that. I think you will do this as a homework, because it looks like a repetition of the same method that what we are using. Let us quickly move to the next problem. If there are any different problem, I can tell you that. So now this also looks like minus 107. Minus 107, if you, since it is cube, I can take minus out, okay, and write it as minus 107 cube. Okay, so anyway, because if you multiply minus 3 times, it is going to be remaining as minus only. That's why I'm able to take minus out. Okay, and write minus as it is, and write this 107 as 100 plus 7. Okay, 100 plus 7 whole cube. Now you do that 100 plus 7 as a plus b whole cube, and keep the final answer with minus symbol. Okay, that's all this value will be. Okay, so I think you will do that. 100 cube, that is a cube, minus 3 a square, that is 100 square, b is 7, plus 3ab square, a is 100, okay, b is 7 square, okay, and minus 7 cube. You will do that. Okay, so I think you do that, and with finally you keep the answer with minus symbol. That's all the answer for this is. Similarly for this also, here also there is a cube, so I can keep minus outside and write 299 as 300 minus 1 whole cube. Here a is 300 and b is 1. You will expand the same thing here and perform the same operation. So since there are similar kind of problems with the same identity, we are doing it here. I'm just giving you it as a homework, and it will be a practice for you also. You will do that. Okay, hope you will do that. Let us move next to the next set of problems, which are little bit different from the other identities. Okay, so factor the following algebraic expressions. So there are some expressions given here by using the same identities again. Okay, so now write a square, it is a square plus 2ab plus b square, looking like a plus b whole square. Let me write this 4y square as 2y whole square. Okay, we have done this kind of problems. So it is 2y whole square plus, I'm writing it in the form of a square plus 2ab plus b square. Okay, remember that. So there is 1 here, but I can do that. 2a 2a is 2y, and see, there is only 1 here remaining constant, 1 in the middle. So I have to cancel both 2 into 2y, that is 4y. I have to cancel only, so that I will get it as 1 here. So I will write it as 1 by 4y as b. So that I will cancel this 2 to the 4y with this 4y, and what remains here is 1. I'm just making it as 2ab. Understood this? Okay, and in that process I got b value as 1 by 4y, and I will just write that as 1 by 4y whole square to make it as b square, and it actually matches with 1 by 16y square. You see that it is matching that. Okay, so you can write that here a is equal to, you now got a is equal to 2y and b is equal to 1 by 4y. Okay, so therefore it is a plus b whole square, so that's why it will be 2y plus 1 by 4y whole square. This is the answer. And if you want, since they are saying that factors, you have to find it. If you want, you can write that therefore the factors are 2y plus 1 by 4y multiplied by 2y plus 1 by 4y. Twice you will write that. Okay, so that is the next step. Coming to the second problem, it is looking like a square minus b square. You see that? Because 9 is a perfect square, 25 is also a perfect square, and m and n are also given in the form of squares only. So I will write this 9m square. Look at here. Okay, listen to me carefully. Okay, 3m whole square, that is 9m square for me. Okay, 3 square minus 1 anyway is a square number only. I will write 1 by 25 as 5n whole square. Now we have a is equal to 3m and b is equal to 1 by 5n. Let me write this as 3m plus 1 by 5n, that is, sorry, 5n it is, that is a plus b and a minus, we are actually expanding this. Okay, a square minus b square, we are expanding it as a plus b and a minus b, that is 3m minus 5n minus 1 by 5n. So these are the factors. I think this is the answer to this. Let us move to the next problem. Next problem is like a cube minus b cube. It is looking like a cube minus b cube because 27 is a perfect cube and 64 is also a perfect cube. So it is looking like a cube minus b cube. So I will write that formula first, or x cube minus y cube. If you remember this, x cube minus y cube is equal to x minus y, okay, multiplied by x square plus xy plus y square. Okay, so there is an identity of this kind. You have to remember and expand this given expression in this form. Okay, let me write 27 as it is actually 3b whole cube. Okay, see, 3 3s are 9, 3s are 27 and b cube. I've written it as a 3b whole cube, and now it is b is now, sorry, 3b is now x for us, and what is y for us? Y is 1 divided by 64 is actually 4 cube. Okay, 4 4s are 16, 16 4s are 64, so it is 4b whole cube. So I've written this in the form of a cube minus b cube. Now I have to expand this with this expanded version. Okay, let me write that as 3b minus 1 by 4b first. 3b minus 1 by 4b, that is x minus y. This is the first part. Second part is x square, that is 3b whole square. Okay, do it carefully, plus xy, that is 3b into 1 by 4b, 1 by 4b, that is xy. Okay, it is y value, plus 1 by 4b whole square, it is y square, the final term. Okay, now let us. Okay, now since there is a b, 3b and 4b here, I can take 4b as the LCM and multiply this with 4b, and that will, so it is 4b now. Okay, it will be 12b square. 12b square minus 1. Okay, now if you are getting confused, I actually wrote it as 3b divided by 1 and 1 4b. 4b, since I have taken it as LCM, 1 multiplied by 4b will get me. Okay, so this is actually 4b. Okay, it is 4b, and 4b multiplied by 3b will get me 12b square minus 1 is the numerator. So this is the first bracket. Okay, second one is 3b whole square will give me 9b square. Okay, and if there is any cancellations, so this b and b will get cancelled, and what remains here is 3 by 4 only constant remains, plus 1 square is actually 1 divided by 4 square is 16b square. Okay, so I think this is the final answer to this. Quickly move to the next problem. X square plus 5x divided by 6 plus 1 by x. Now if you look at the algebraic expression, at the first look you may think that there is no perfect square in the last term or perfect square in the middle term also. Only x square is the only term that looks like helps in identifying our identity. Okay, but what we can do is just multiply this whole equation by 6. That way we can convert this into a algebraic equation which can be factorized and get it resolved. Okay, so let me multiply by 6 so that these 6's in the denominator will get cancelled. That is how you can reduce this formula to a solvable algebraic equation. Okay, so multiply by 6. Okay, later when you multiply by 6 in the beginning, later at the end you have to divide it by 6. Okay, the whole factor should be divided by 6. You should not forget it. Okay, multiply by 6, it will get you 6x square. Okay, plus 6 with this 6 will get cancelled, and what remains here in the middle term is 5x. Again 6 into 6, this 6 and 6 will get cancelled, right? So what remains here is 1. So you see now this algebraic equation looks like 6 into 1, the product is 6, and I have to get the two factors such that the product is 6 and the sum is 5, and that is 2 into 3. You know that. Okay, so many times we have resolved such problems. So it is 2 3s are 6 and 2 plus 3 5x. Let me write this as 6x square plus 2x plus 3x plus 1. Okay, again take commons from the first two terms, that is 2x comes as a common thing. Okay, and what remains here is 2 3s are, that is 6, and x into x square, so it is 3x. See, 2 3s are 6, x into x square, and the whole 2x got out, so 1 remains here in the first term. Again see, 3x plus 1 3x plus 1, so there is already a 3x plus 1 term on the right side, so I have to take 1 as common. Okay, so don't do mistakes here. Okay, you cannot say nothing is common between these two. There is 1 always common between all the terms. Okay, so don't do a mistake at this step. Okay, be careful here. So I have taken 1 as common, so that I am left with 3x plus 1, and this 3x plus 1 are common now. Okay, do this step very carefully. Okay, 3x plus 1 common, so what I am left with is 2x plus 1. 2x plus 1. These are the actual factors, 3x plus 1 and 2x plus 1, but we have initially divided by 6. This whole expression is multiplied by 6, so I have to now divide this whole factor by 6. So finally you can say that divide by 6 to this factor, and that is 3x plus 1 and 2x plus 1 divided by 6. This is what the final answer to this algebraic expression. Okay, let us quickly move to the next problem. So the fifth problem looks like the expanded version of a minus b whole cube. Okay, listen to me carefully. Okay, so this is a cube plus b cube. We will do that later. Okay, let us rewrite this in the form of a minus b whole cube expanded version. Okay, listen to me carefully. This is a very important one. Let me write this 27u cube as 3u whole cube. Okay, it is 3 3s are 9, 9 3s are 27 u cube. Now it is a cube. Okay, next term in the expansion is 3a square b minus 3a square b. Remember this. Okay, minus 3a square is 3u whole square, right? A square b. Okay, now let us see the already written values and see what term it matches with. Okay, now I have just written, remember this. Okay, listen to me carefully. It is 3 and 3 3s are 9. 9 3s are 27. 27 u square. See, this is that term that I am dealing with now. Okay, it is actually my 3a square b term minus 3a square b term. Are you getting my point? So it is already 3 9s are 27 u square, but there is a 5 here. So I want that 5 also, and I will write that as 1 by 5 here. So now it gave me the value of b, and that is 1 by 5. You got my point? Now let me write the next term, that is plus 3ab square. 3a, and what is a? We know already, that is 3u, and b square. What is b? 1 by 5. In the previous step only I got it. So that is 1 by 5 whole square. Now let us check whether there is any term that matches with these calculations. Okay, you see that 3 3s are 9u, and it is 1 only, so there is no change in this value. It is 3 3s are 9u in the numerator, and divided by, it is 5 square 25. See, this is that 9u divided by 25. So it is my 3a square b, and this is my 3ab square. Okay, that you have to do it carefully. And finally what remains is this we have written. So finally this should be my b cube, right? So and also it is with minus symbol also. So finally I will write this as minus b cube, that is 1 by 5 cube, and it gives me 5 cube as 1 by 25. That's all. So we have written it in the expanded version of a minus b whole cube. Okay, so you can write that as, we know that, you can write that also, that a cube minus 3a square b, this is what the term we have expanded, right? Plus 3ab square minus b cube is equal to a minus b whole cube. Okay, so this is the identity what we have now expanded it, where here a is equal to, let us write what is a, because we have to do it carefully. A is 3u, and what is b? B is 1 by 5. 1 by 5. So therefore it is 3u minus 1 by 5 whole cube. So this is what the factor of this. Let us look at the sixth problem. Now, as I already told, this looks like a cube plus b cube formula, and let me write this as a cube is actually, as I already told, it is 4 cube. Okay, so 4 4s are 16, 16 4s are 64. I can write it as 4y whole cube plus 125. We know that it is 5 cube and z cube. So I can write it as z divided by 5 whole cube. It is looking like a cube plus b cube, where a is 4y and b is z by 5. Okay, now what is that formula? I will write this as x cube plus y cube is equal to x plus y multiplied by x square minus xy plus y square. So this is what the identity we have studied in the previous session. Okay, you have to remember. If you know the identity, remember the identity, then it will be very easy for you to solve such problems. So now we know that what is x? X is 4y. Okay, here x is 4y and y is z by 5. Z by 5. Let us substitute those in the expanded version. It is in the left side version. Okay, we have to expand this. in the right side version. It is 4y plus z by 5. It is x plus y, okay, and x square, that is 4y whole square, okay, minus xy. What is x? X is 4y. Do it carefully. Again, I'm telling you, y is z by 5, z by 5, that is xy minus xy, plus z by 5 whole square, that is y square. Okay. Now, if you want, you can do again the LCM. Take the LCM, and it will be 5 in the denominator, 5, and it is 1 here. So 1 5 is a, it is 5 4 is a 20 y plus z it is. So it is the first bracket. Second bracket, it is 4 square. Do it carefully. 16 y square minus 4yz divided by 5. There cannot be any cancellations. So minus 4yz divided by 5 plus z square divided by 25. Z square divided by 25. Maybe this is the final answer. Okay. Now, yeah, as I already told, you have to first look into all the identities, then only go for resolving all these problems. Okay. So this might be a little bit looking similar problem also, and repetition also for you. And also, if you don't know the identities, it might be difficult for you also. Okay. But since I have done so many problems of the similar kind in the previous sessions, I'm going a little bit faster if you are feeling it faster. Okay. Now let me write this again. There is a new identity that you are dealing with here. Okay, it is a cube plus b cube plus c cube minus 3abc, or x cube plus y cube plus z cube minus 3xyz. We had this formula, if you remember. Now let me first write the identity that matches with this, and that is x cube plus y cube plus z cube minus 3xy z. Okay, and that was equal to, if you remember, it is x plus y plus z, and into another bracket it was x square plus y square plus z square. You remember this? Okay, we had resolved this using this identity. We have resolved some multiple problems on that. Okay, it is xy, all the minus terms. Okay, minus yz minus xz. Okay, this was the identity what we had already studied. Okay, make a note of this identity, and this is the identity what we are using here. First of all, we need to convert this into the left hand side format so that we can write it in this format. Okay, do it carefully. P cube as x cube, we already know p cube. Okay, plus 27 cube, I will write it as 3q whole cube, making 3q as my value of b, plus r cube, that is my x cube, minus 3, and we know that p is x for me, q 3q is b for me, that is, and finally yz. Okay, you see that 3 3s are 9 pqr, that is 9 pqr, and it is 3xyz. Understood this? Okay, now let us have the values of x as p, y as 3q, and z as r. Let us substitute those into this expanded version. Okay, do it carefully. It is p plus 3q plus r in one bracket. Next is, it is x plus y plus z. Now it is p square, okay, plus y square is 3q whole square, okay, that is y square, plus z square is r square, minus xy, x is p, okay, and y is 3q, minus yz, y is 3q, okay, and z is r, and finally minus xz, xz is p into r. This is our second term. Just do the final multiplications, and that will be the answer. It is p plus 3q plus r in one bracket, and another bracket it is p square plus 9q square, okay, plus r square, and minus 3pq minus 3pq as xy, okay, and minus 3qr is yz, 3qr is yz, minus pr is xz. I think this is the answer to this. Okay, but to do this, you have to remember this identity and apply that identity and do all the multiplications carefully. Okay, let us quickly do the next one. Next one looks like easier to me. Okay, it is a square minus 2ab plus b square. It is looking like that. Okay, so 9 is a perfect square. That's the reason I told it. So it is 3m whole square. Let me write that in the form of a square minus 2ab plus b square. 3m is a for me, so I will write it as 2 into 3m. So it's already 2 3s are 6m is already there. So what I want is 6 2s are 12. So 2 is b for me. So I will write it as 2b square. Now see, it's very easy that I've written it as a square minus 2ab and b square. See, it is 4 square now. Okay, done. So what is a here? A is 3m, and what is b? B is 2, and what is this expanded version is of a minus b whole square. Therefore it is 3m minus 2 whole square. See, at this stage they have given a very simple problem. Okay, after resolving such problems we are using, so that's the reason I told, again I'm telling you that it is a combination of a mix of all the identities. This a minus b whole square identity we have done it in the very beginning sessions. Okay, so let us quickly move to the next problem. Now the problem number 9 is looking like some matching with some identity, but we have 3 in the denominators of the two of the terms. Okay, if you cancel out those, it will be helpful for us to decide about any of the identities. Okay, so let us multiply this whole expression by 3 so that I will get these 3's in the denominator cancelled. Okay, so let me say multiply by 3. Okay, so multiplying by the 3 to the first term will make it as 3 nines are 27 x cube. Now you see, 27 is a perfect cube value. Okay, and 8 is already a cube value, so if I cancel 3 by multiplying to this, it will be 8y cube. Again, if you multiply 3 to this term, this 3 will be getting cancelled and it will remain it as z cube, and plus you have to multiply this 6 also with this. Okay, it is 18xyz. Okay, now how it is looking like? It is a cube plus b cube plus c cube minus 3abc. Okay, that formula it will be looking like, but as I already told, this should be minus and there should not be any minus here. Okay, so we have to think in that way that if this is becoming minus, it is the y value that is making this term as minus, and since there was already a minus here, and the minus y value will making it as plus. Okay, you're getting my point. So let me rewrite this so that I can apply the formula of this one. Okay, let me first write that x cube plus y cube plus z cube, we have just used that into the previous problem, minus 3xyz. Okay, I'll be writing this whole term to this formula. Okay, remember this. Okay, listen to me carefully. The term here is plus, I have to write it as minus. The term here is minus, which I have to write it as plus. Okay, what is the expanded version of this? You have to remember this identity. Okay, it's very important. Okay, now let me write this whole thing into this format plus so that I can expand it in that way. Okay, make a mark to this. Okay, I will write 27x cube, listen to me carefully, as 3x whole cube. That will be x cube for me. Okay, then y cube. See, y here it is 8y cube they are writing, but with minus sign. So I will write this as minus 2y whole cube. You're getting my point? See, minus when it is multiplied 3 times will give you minus. So this term's symbol sign will remain as minus only, and it is 8 2 cube, that is 8 and y cube. Okay, so when I substitute this minus 2y into the last term, this will make it as a plus. That is the reason I'm doing this. You're getting my point? It's very, very important step. You should not make any mistake here. And this is z cube for me. Z cube is z cube only. Minus 3xyz. I have to write it as 3xyz. This format I have to write, right? So I will write it as 3. And what is x? X is 3x for me. I will write it as 3x. Okay, and what is y? Y is minus 2y, so I will write it as minus 2y, and finally z is z for me. You see that now if you multiply all this, this will obviously going to get you plus 18xyz. Do this. 3 3s are 9, 9 2s are 18, and that too with minus and minus plus 18. This is x, y, z. See, 18xyz with plus sign. Understood this? But we have expanded this to match this left side of this x cube plus y cube plus z cube minus 3xyz. Okay, hope you understood this. Now coming to expanding this whole thing into this format, let us expand that. X plus y plus z, that is 3x minus 2y, that is plus y only, plus z, it is x plus y plus z. Now coming to x square plus y square plus z square. X square is 3x whole square. Don't write it as 3x square, okay? 3x whole square, because 3x itself is x for us. Okay, remember this and do it carefully. Again and again I'm telling you. Plus minus 2y whole square, minus 2y whole square. It is y square for me. Z square, next term is z square, and z is z only. There is no change in that. Okay, now coming to minus xy. What is x? X is 3x. Okay, and what is y? Y is minus 2y. So I will write this as minus 2y. Next comes minus yz. What is y? Is minus 2y. And what is z? Z is z. Okay, minus zx. Z is z only, and x is 3x. Okay, hope you got this. While doing this expansion, you should be very careful about the signs and the values of x, y, z. Okay, now there is no change. Let us write the final step. It is 3x minus 2y plus z as the first bracket. Okay, and then coming to the second bracket, it is 3x whole square, that will give us 9x square, and minus square minus 2 square will give you 4 plus 4 only. So let me write this as 4y whole square. Z square remains as that z square only. Minus into minus, this term will make it as plus, and 3 2s are 6xy. Okay, it is plus 6xy. Again minus into minus will make it as plus, and 2yz, 2yz, and minus 3xz, minus 3xz, and this is the second bracket. Think this is the final answer to this. Okay, one more step. Okay, sorry, I forgot. I told you that since we derived or arrived at this answer by multiplying the actual expression by 3, so we have to divide by 3 also. Okay, so the whole thing, so final step, we have to write it here, divide by 3, and the whole thing is divided by 3. So this is the final answer. Let us quickly move to the next problem. Okay. Okay, now next problem I have given a red star here, because what I observed is there is a small change that we need to do it in these two terms. Okay, it should be actually 12xy and 24xz. Okay, you have to make that correction. Instead of z here, it should be y. Okay, that is what my observation is. Unless and until you do that change, you will not be getting any perfect squares or perfect identity. It matches. So, and this y should be z. Okay, so this change you have to do it in your book also. I think this is the mistake that is given. Okay, that's the reason I just marked it with a red star. Okay, now it is now will match it as a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and what is that identity is a plus b plus c whole square. Okay, so let me write this now as 2x whole square, that is a square, plus b square, that is 3y whole square. Okay, and c square, that is 36. Okay, it is 6z whole square. Okay, it is a square plus b square plus c square. Now I have 2x as a, 3y as b, 6z as c. So I can directly write this as 2ab. What is ab? 2x, and b is 3y. B is 3y. It is 2ab. Okay, now that's the reason I told this change. You can observe that here. 2 2s are 4, 4 3s are 12, 12xy. It was actually xz. Okay, there is only one term with 12 as the coefficient, and it should be xy according to this x and a and b value. It should be actually x and y. 2 2s are 4, 4 3s are 12xy. Okay, even that matches with this last term also, you'll come to know that. Okay, it is now 2ab. Okay, next is 2bc. Okay, what is b? B is 3y for me, and what is c? C is 6z. Here also you can see that it is 2bc. 2 3s are 6, 6 6 the 36. It is the middle term, it is 2bc and yz. Understood this? This is 2bc. Now coming to the last term, 2ac, right? 2 into a, and a is 2x, and c is 6z, right? You see that 2 2s are 4, 4 6 are 24, 24xz, 24xz. So that matches only if you exchange this z to y and this y to z, then only this matches. I think there is some typographical mistake that is done into the textbook. Okay, so I think now we have expanded that into the form of a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Okay, or 2ca you can say, and that is equal to a plus b plus c whole square. This was the formula that what we expanded now. So now we already have this form, this left side value. I can directly write it as a plus b plus c whole square, and therefore I can write this as 2x plus 3y plus 6z whole square, where a is equal to 2x, a is equal to 2x, right? 2x, and b is equal to 3y, and c is equal to 6z. So this is what the answer to this. But provided I told you that this small exchange of y and z should be done, then only you will get the answer. If you keep that way only, you will get some random answer which will not be matching with any of the identities that what we have studied. Let us quickly move to the next problem. Okay, now if you look at the next problem, this is looking like a minus b whole cube, because see, it is a perfect cube. 27 is a perfect cube. 2 1 6 is also a cube of 6, and this is this can be treated as 1 by 6 whole cube. This can be treated as 1 by 6 whole cube, and that makes it as minus b cube. This will be some minus 3ab square or a square b, and this will be plus 3a square b or ab square. Okay, let us look into this and rewrite this as 27 u cube. I will write it as 3u whole cube. Okay, that makes me that gives me the value 3u as the value of a. Okay, it is a cube now, minus b cube. I will write b cube at the end. Okay, let me write 3a square b first, because I have the value of a here. 3a square. What is a square? It is 3u whole square. Now what is the value that you are getting by writing this a square term is 3 here and 3 square, that is 9. Okay, 9u square. So there is a term by 9u square here, but if you multiply that with 3, that will become 27. But if you observe the below term or the denominator here, there is a 2 here. So if I write this, if I want this 2 to be written here, then I have to write this as 1 by 6. Okay, listen to me carefully. Why I am writing this as 1 by 2? Because 3 ones are and 3 twos are will get cancelled here. Okay, you see that 3 ones are and 3 twos are will get cancelled, and what remains in the denominator is 2. And what is there in the numerator? 9u square divided by 2. So this term will actually give me 3a square b, and the value of b is 1 by 6 for me. Understood this? Okay, you have to make such adjustments, okay, with trial and error, then only you will get the answer. Okay, so the next step is 3ab square. Now it is a square b term is done. Now 3ab square. What is a? We know the value as 3u. We don't have to worry about the b square term because we have already adjusted the value. I can directly write this as 1 by 6 square. It is ab square. Okay, now you check the value whether there is anything that gives us the this term. Okay, 3 3s are 9u. Okay, 9u divided by 36. Okay, there is a 6 square here, right? So it is 9u. So let me write that 9u, and what is 1 by 6 square is 1 by 36. Okay, so it is 9 ones are and 9 fours are. What remains? U into 1 divided by 4. It is u by 4, and this is that term. Got my point? Okay, so we have already written the 3ab square term also, and this is that 3ab square term. Now you can just simply think that 1 by 6 is the b value for us, so I can directly write this as 1 by 6 whole cube with minus symbol, and that term matches with 1 by 216, and that is 1 by 216. 1 by 216, that is 1 by 6 whole cube. Okay, so now we got a cube minus 3a square b plus 3ab square minus b cube, and here you can now write it as a cube minus, okay, let me write that, a cube minus 3a square b plus 3ab square minus b cube is equal to a minus b whole cube. So this formula we are going to use it. We have already have the left hand side where a is 3u and b is 1 by 6. So therefore it is 3u minus 1 by 6 whole cube, where a is equal to 3u and b is equal to 1 by 6. So this is what the answer to this expanded version. Now you might be thinking that why I'm doing all these adjustments, because I know the identity and the given expression will give this expansion to me. Okay, I know that because I am aware of all the identities what we have studied. Okay, so this is the only way that you have to remember the identity and expand the given expressions into the form which can match some of the identities. That will make our job easy. Understood this? Okay, let us move to the next set of problems. Okay, now this is the fourth set of problem, simplification of the algebraic rationals. Okay, now let us stop our discussion here only, because we have spent more than an hour of time on these examples only. Let us look at these remaining problems from 4 to 13. I think 13 or 14 problems are there in the end of chapter exercises. Let us continue our discussion on these remaining problems in the next session. Okay, thank you.